rapid transit system is the largest, most complex and ambitious public works project in the history of Singapore. Completed ahead of schedule and within budget, the MRT is a delight to look at and to use. The studies started 20 years before it opened. Although traffic conditions in Singapore were improving, the experts agreed that continued improvement demanded mass rapid transport, and detailed studies followed. After a lot of debate between the all-bus and rail and bus lobbies, the go-ahead for a rail system was given in 1982, with a budget of 5 billion Singapore dollars. By making a decision to build that year, two factors were in Singapore's favor. The prevailing world recession meant contractors would bid low to get the work, and the completion of the Hong Kong MTR meant that a lot of expertise and equipment was ready and waiting. Once the decision to build was taken, things moved quickly, and a deadline of 1992 was set for completion of all phases. When tenders were called, preference was given to foreign joint ventures with local companies to encourage the transfer of technology. The final routes were drawn in 1983, linking the new towns with Orchard Road and the Central Business District. 20 kilometers ran underground and 47 above. With all phases complete, the system would have 42 stations. On August the 30th, 1983, Parliament passed control to the Mass Rapid Transit Corporation, and the first ground was broken at Shan Road. Parliament had given the corporation the right to tunnel under private property and to build viaducts over it. Over and under they went. Two methods were used to go underground, according to soil and area conditions. The first method was to bore using a shield to carve directly into the face of the tunnel. The shield jacks itself forward, passing soil and rock back on conveyors. The shields used laser beams to align themselves. More than 1 million loads of earth were carried out by 1,000 lorries. Some of it was used to reclaim land from the sea. More than 1 million segments of tunnel wall were precast for Phase 1. These were aligned and bolted in place behind the advancing shield, forming an immensely strong watertight tube for trains to run in. As most of the boring was done below sea level, air pressure was raised inside the tunnel to keep the water out. Like deep-sea divers, the workers had to decompress at the end of every shift to avoid the bends. The Singapore Navy helped here, keeping an eye on procedures and giving the workers regular medical checks. Much of Singapore sits on soft, sticky marine clay. The conditions beneath Robinson and Scott's roads were particularly soggy. The ooze could not be held back by air pressure alone, and jet grouting was needed. 5,000 holes were drilled, and a grouting mixture of cement and soil was pumped down to solidify the clay. Tunneling then went ahead quickly. The first tunnel breakthrough came in mid-85. The second method used for underground construction was cut and cover. It was used wherever the area above was clear. A deep, wide cut was made between piles or diaphragm walls. The tunnel or station was built inside it and then covered. All the underground stations were built this way. On several sites, diaphragm walls of reinforced concrete were cast in narrow trenches where heavy mud supported the sides. In more stable areas, soldier or sheet pile walls were used. To cross the Singapore River, a double sheet pile coffer dam was driven to hold back the water. The riverbed was pumped dry, the tunnel structure was built in a cut, and then a solid metre of concrete was used to seal and protect it. After flooding, construction could begin on the other side of the river. Several lines in the system met in this area, and the crossing had to let trains change lines. This double-level crossover went below the standard chartered bank. Its foundations were built to suit the MRT. The 47 kilometers above ground followed some of Singapore's busiest roads. Keeping the lanes open and traffic flowing smoothly was very important. To build the viaducts, concrete beams weighing up to 165 tons were cast, then raised to a gantry and carried along the completed viaduct to be dropped into place on the crossheads. Up to 56 beams a month were launched in this way, while traffic flowed with almost no interruption below. The last beam in Phase 1A was launched on the 27th of November 1986, months ahead of the original schedule. It signaled success for the corporation's speed-up of the whole construction program. The new deadline for completion of all phases was moved from 1992 to 1990. 6.5 years for 67 kilometers. But building a railway, no matter how beautiful when finished, causes some disruptions, some temporary diversions. Things returned to normal quickly once construction was completed. Singapore has a reputation for being clean and green. Contractors helped maintain it by washing every lorry before it left a muddy site. Noise was constantly checked and working hours adjusted to avoid things like school examinations. A machine was used to simulate the noise and vibration of a passing train to check on sound control measures before the trains ran. Block 206 Toa Payoh was the only residential building affected by tunnelling. Some families had to move out while new foundations that made room for the tunnel were put in. Then the old piles that were in the way were cut out. Community relations programs kept affected residents up to date on all construction plans. Talks were given and questions answered. An MRT hotline was set up and backed with full investigation for all complaints. Great care was also taken to preserve buildings of historic interest while tunneling below them. The ground beneath the chapel of the Convent of the Holy Infant Jesus was heavily grouted, and the works below the Sun Yat-sen Villa and many other old buildings were carefully monitored. No one wants to see the past damaged by the march of progress. Miles of cables were laid for the complex communications and control systems. As part of Singapore's civil defense network, 9 of the underground stations were built to be totally self-sufficient. All electricity, water and air conditioning supplies and the tunnels themselves were protected by special blast doors, filters and sliding walls which could completely seal the stations in an emergency. Over 190 kilometers of rails were laid in 18-meter sections. The sections were thermite welded for minimum wheel noise. Conventional ballasted track with wooden sleepers was laid above ground. And pre-assembled slab track with concrete sleepers underground. With some floating sections in areas near flats and commercial buildings to avoid noise and vibration. An insulated rail runs beside the track, supplying 750 volts of electricity to the trains. This third rail system was chosen for its efficiency and to avoid unsightly overhead cables. The rail cars were built in Japan and began arriving on schedule in April 1986. Their size and weight meant that they had to be moved at night by road from the docks to Bishan Depot. More than 5 times the size of Singapore's National Stadium, Bishan Depot houses the administration and training facilities, including a full-scale model of 8 stations with full-size control panels and mimic diagrams. A cab where new operators can develop and practice their skills watching a video simulation. A test track where trains can be put through their paces with sandbags standing in for people. Regular maintenance and repair, washing, cleaning and stabling of trains. These are all done at the Bishan depot. There was a clamour to board the first train in November 1987. As more sections opened, it was love at first ride. The trains were fast, clean and cool. All the above-ground stations were designed to blend with their surroundings. Some were designed with special architectural features that would emphasize the character of a neighborhood. 5 of the underground stations were planted with underground gardens to prove that Singapore is a garden city. Local artists were given commissions worth 2 million Singapore dollars for murals and artworks for 6 stations. A decision was made early in the design process to save as much energy as possible throughout the system. Platform screen doors reduce air conditioning loss as well as holding back the blast of air from an approaching train. With regenerative braking, trains actually put electricity back into the third rail when they're slowed down. And the trains are built to freewheel downhill. The high-speed, high-volume escalators run on reduced power during off-peak hours. The MRT control system is computerized and links every station and every section of track to the operations control center next to City Hall station. All MRT operations, from temperature control to accurate train stopping, are checked by computer. The controllers have a direct radio link with the drivers at all times. The signaling mimic diagram gives an overview of the system. Train positions are shown by colored lights. Controllers can call up any section of the system on their monitors. As a safety measure, all the optic fiber cables that transmit data are duplicated, and the computers in each station can take over if any breakdown occurs at the control center. To keep a safe distance between trains while keeping them on time, computerized signaling relays continuously update their speed and status. As a train approaches the one in front, it is electronically told to slow down or stop. When the train in front pulls away, codes start the one behind it and speed it on its way again. With the security of 3 power supplies, both central and local computer control and video links, Singapore's MRT system promises to be one of the safest in the world. Automatic ticket dispensers, change makers and stored value tickets promise it will be one of the easiest to use. With 30% of all Singaporeans living within walking distance of a station, 40% of all business and industry near one, and a full 50% of the whole population living within 1 kilometer of a station, the MRT is going to be one of the handiest systems ever. It will be a fast, efficient way to get to work, to the shops, to visit, to go out to eat, to dance, to travel. It will stop the roads getting more crowded every year. It will save billions on road construction. It will make life better for everyone who lives or just visits Singapore. In 1990, 2 years ahead of the original schedule, 66 trains will be operating with 6 cars each. By the year 2000, they should be carrying up to 1 million passengers a day in quiet, cool, colourful comfort. No doubt those million passengers will wonder how they ever got along without the MRT.
A vision fulfilled, the MRT story is a Mass Rapid Transit Corporation production.